Hello and welcome. Today's video is going to be on two power supplies that I've built. I've not actually made a video in a long time, so basically I've been busy doing work and uni stuff. Yeah, so basically one of them's a linear supply and it uses a buck converter / boost converter to vary the voltage output. The other one's a modded ATX power supply where I've just taken the output power lines and connected them to binding posts, which is a common mod that I've seen on YouTube, so I thought I might just do it as well because it could be handy. Anyway, so here's a couple of clips I filmed. Enjoy, thank you. So this is the internals of my ATX power supply conversion. Basically what you do is you take the cables that come with the power supply and terminate them onto binding posts depending on their voltages. So the blacks are 0 volts, the orange is 3.3 volts, red's 5 volts, yellow is, ignore this wire, yellow is 12 volts. Grey, I believe, is minus 5 volts for driving like op amps and stuff. And then finally, I've forgotten what the last one is. I think it's purple. Yeah, it's purple. Purple is negative 12 volts. There's also a wire for an on LED and one for just a standby LED. So I've added those on the side here. I've forgotten what colour they are. It usually says on the side. That one seems to be grey. I did this like last week, so I can't really remember. But and blue would be the standby LED. So anyway, you can look at that. It depends on the power supply. But so I terminated all these. The green is the actual signal for turning the power supply on. So what happens is the motherboard normally shorts that to ground. So I've just used a toggle switch to do that. So it's green and a black wire from the 0 volt rail. What I've also done is I've added a variable supply on the side here, which obviously sits up on the cover. So what that is I've got 0 volts and 12 volts going to, well, 12 volts goes directly into the input of the variable buck converter. Sorry, I'll move the camera. So 12 volts goes directly into the buck converter, but I've also got a switch here. So what happens is the 0 volts goes to one terminal of the switch, and then negative 12 volts goes to the other terminal of the switch, and then the output of the switch goes to the input of the buck converter, which means that I can either have 12 volts variable, like so between 0 and 12 volts output, and that's about 22 amps it can supply. These buck converters actually are 200 watts, but and the power supply rail, the 12 volt rail can supply up to 22 amps, I believe. So that's one position on the switch, but I can also switch it to the other position, which goes between 12 volts and negative 12 volts. But so it's variable 24 volts, but that can only supply 0.5 of an amp. But you know, it just gives you more variation of like options. And these are the binding posts for the output of the buck converter. I mean, it all looks very, 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 very sloppy. One thing that other YouTubers haven't really mentioned, I know these things are dangerous, but this plate here, if that's got power going to it, it can store, I think it's 170 volts. I don't know, it's normally a heatsink. Well, it looks like a heatsink, but that's something not to touch, really. The other thing you have to do is these switch mode power supplies are unstable if they've got a no load. So what you have to do is take one of your voltage rails and a 0 volt rail and put it into a power resistor. It's called a dummy load. So basically what you do is that draws a certain amount of power from the power supply to stabilize it. In my case, you should go for the rail that's got the most power. So it says on the side of most ATX power supplies in this here, it says basically what each rail is rated for. So the one that's got the most power, you put the dummy load on. So it's 5 volts, between 5 volts and ground in my case. So that's about it. It's kind of quite tight to get all this shit inside. I should have shortened the cables, but I already put connectors on them, so I wasn't going to waste my time. So to start the power supply, you turn this on and the little green LED comes on and the fan comes on to help cool it. So the voltage outputs are we've got 3.3. So we've got 3.347 volts there, 5.1 there, 11.96 there, and then this one's negative 4.752 and 11.47. On this side here, I think you have to turn down the buck converter before switching to one of the options. So on one side you've got a variable sorry, it's quite tricky to do this with one hand. So yeah, between 11 and 0 volts there. And the other option, that you have to turn off the buck converter to actually switch it, otherwise the power supply stalls. The other option is, sorry, there's little holes but I've not actually aligned them properly, it's a pain in the ass. So this gives you a variable 24 volts. Well, 23.1, but yes. So you can have any voltage you want there. So it's actually quite a useful power supply. So the danger with these power supplies is the fact that they store a lot of power even when you unplug them. So I'm unplugging the RUC cable now, and if you can see the fan now, I'm actually going to turn the power supply on again. and that fan will run for a couple seconds. So the capacitors inside them store high mains voltage DC, and then they actually switch it to lower the voltage for a transformer. Actually, the mains is rectified first, and then there's a switching circuit, and then it goes for a transformer to step down to lower voltages. So the smoothing capacitors after the rectification are holding like 230 volts. Well, more than that, it's actually the peak voltage of the main supply, so it's 320 or something volts, so that's actually quite dangerous, but anyway. So this is the other power supply I built. It looks like an ATX power supply mod, but it's actually completely, well, custom, I guess is the word for it. But yeah, so I had a dead power supply, so I used this as a enclosure for it. So they're the two binding posts on the side, and it's got a 4-button menu. So that's you press that to actually turn the power output on, up and down for the voltage and current limiter, and that actually sets it. So once you've chosen a voltage or current, you actually press the set button and it will save that even when you turn the power off. So and it's actually just got the original connectors on the back. Obviously on a normal power supply, like a normal ATX power supply, the fan's on the inside, but I put it on the outside so that I'd have more space for stuff inside. So we'll open this up to show you what's going on inside. So the other power supply in the last clip was a switch mode power supply from a computer, and this one is a linear power supply, which I quote unquote designed myself. So okay, so again, there's not much wiggle room really, but I actually forgot that how this is put together because I did this like last year. So what we've got here is under this, God, that is sketchy, isn't it? Don't you agree? So the power comes in here, it goes through a transformer. Under this tape here is a linear regulator module, so it's got the bridge rectifier and then a smoothing capacitor and a 12 volt regulator or something, I can't really remember. Doesn't really matter that much. So the diodes are actually rated for 10 amps, I believe, so it's actually it's a lot more. Yeah, so yeah, the diodes are rated for 10 amps. Anyway, so the output of the linear regulator goes into this eBay buck/boost converter. So the output goes in, and you can choose any voltage between 0 and 50 volts. So even though it's got a 12 volt input, it will actually boost the voltage to a higher voltage, or it can reduce the voltage, which is quite handy actually. I'll put a link in the description where you can get them. I have correctly earthed the case of the thing. So anyway, the module actually has a 4-button menu on the side, which I mentioned before, but it was usually on the board. On the actual, that part there was just, I had a header on the board there, but I used cables so that I could put it on the side of the case. And the output just goes to those two binding posts. So it's fairly simple, but yeah, no, it's quite a handy little thing to have. Just push those back in. Oh god, they've all fallen out. Oh no! Anyway, so I managed to get that ribbon cable connected again. Bloody pain in the ass. I'm tempted to put some super glue to hold it in properly, but the problem with super glue is then it covers all your terminals and then it won't conduct properly. Bit of tape, I think. Okay, there we go, happy days. So I'm just going to close this up again. This one doesn't actually have a on-off switch, just the one on the back. Fan still runs because there's actually a header on the board of the boost converter, so that's quite a handy thing. So as you can see, at the moment it's, well, maybe you can't see, I'll just move the tripod. This video is going to be crap, I'll tell you. So this is another case of an unfinished device. So this is another case of an unfinished device. I plan to put labels on this here, but I don't actually have a labeling machine, and I plan to label the other supply, but I'll get around to it in 20 years time. So so this button here will actually change the voltage up. I can't remember how high it goes, but you just hold it until you get the voltage you want. The LCD is not really coming that up on that camera so well, but we're at 36 volts, I mean. So it goes up to 38 volts, which is quite handy. It will burn out pretty much any motor that you've got. And then the other button turns it down. This button on here actually sets the voltage that you output so it remembers what voltage you had before. And then you press this button to actually output it, and then it comes up with how much current's being drawn. There's a little green LED that tells you it's outputting. There's a red LED, can't remember what that means, who knows. And there's an actual orange LED that comes on when you're drawing too much current for the board to handle. Anyway, you can actually set the current limits as well by pressing the set button twice. But if I unplug it, it takes a wee minute to go off because there's a 10,000 microfarad capacitor in there. If I plug it back in, it goes back to 12 volts automatically. So I'll show you if I was to go 12, 13, press set, that's it, set now. Should be able to unplug it, plug it back in, and it goes back to 15. Why did I say 13? I meant 15, so there we go. Do that again. Yeah, back to what I set it at. But I like it 12 volts because 12 volts is a good voltage. Oops, went way past it. I was retarded. And the actual output voltage is at, even though it's made on eBay, stick the meter on it. Oh god, that is really bad, William. Oh yeah, I need to actually turn it on as well. There we go. Oh dear. So, and turn the meter on. Good job. There, so it's 12.05, which is, oh dear. Come on. Why is that not? It's really hard to do this through the lens. Yeah, so 12.05, and the output should be 12.0. So it's quite good.